Okay, if you take a look at this one, we're being asked to prove. So first thing you want to remember is that when you're proving something, one side stays the same no matter what every time. So I'm going to keep my right side the same. The side that looks more simplified is normally the side that stays the same. What I'll usually do is just write a bunch of steps that have that right side the same so that I remember not to make any changes. Okay, the part that says where x is not equal to positive or negative 2, remember the idea of that is if I had positive or negative 2 in the denominator, it would make the denominator equal to 0, which makes the whole thing undefined, and that would not work. So that's the point of that. Alright, so we're going to simplify the left until it is equal to the right. And so in order to add or subtract fractions, remember what we have to have is common denominator. So if you take a look, there is currently only one denominator. Right now, 2 has a denominator of 1, so the easiest thing to do would be to give that same common denominator to the first term. Anything you do to the denominator, you do to the numerator. Remember, we're only doing this through multiplication. We never add or subtract into a denominator. Okay, so now the left side all has a common denominator of x squared minus 4, which allows me to write it as a single fraction, and I need to simplify the numerator. So I distribute the 2 to the x squared minus 4 that I just multiplied in. And then I also have to be really careful to remember that I have a subtraction sign here, and I'm subtracting that entire second numerator, which makes it minus x squared minus 6. Okay, as I continue to simplify on the left, I'm going to combine like terms in the numerator, so 2x squared minus x squared gives me x squared. Negative 8 minus 6 gives me minus 14, and that's all over x squared minus 4. And if I look at my right side, I originally had x squared minus 14 all over x squared minus 4. So now the left is equal to the right. I've proved it. I have to have both sides equal to show that I've completed a proof. I'll do a